Thanks for watching this screencast. This screencast is about writing linear equations. The objective is that learners will be able to write the equation of a line given a point and its slope. So we start the screencast off with a question for you. And I'm going to read the question to you. I'm going to ask you to pause the video and think about it for a minute, and then hit play when you think you've got an answer. Suppose you know the slope of a line and one of its points. My question is, how could you use the slope formula below to find all possible other points on the line? Hit pause for a minute, Panther. See if you can figure out a plan or a process or a thought, and then hit play and we'll check it out. Panther, something that I hope that maybe you thought about is if I knew one of the points and I knew the slope, suppose I were to choose to put one of the points that I know maybe here and here, the x and y coordinates, and I also know the slope. This would be a known value as well. I could use the other x and y coordinate locations to write a little equation that would describe every other point on the line. In fact, if I wanted to take that equation and write it in a more familiar form, I suppose what I could do is I could multiply both sides of this equation by the difference of x2 and x1. That's a legal move. Remember, that's a multiplication property of equality. And what I suppose would happen here on the right side of this equation is that the x2 minus x1s would divide each other out, and I would get an equation that I hope is somewhat familiar to you, that the difference of the two y's that we're dealing with is the same as the product of the slope and the difference of the x's, which I'm going to rewrite this way. And I hope that looks really familiar to you from your studies in Algebra 1. So in fact, here is the real deal, the point-slope form of the line. The point-slope form of the equation of a line is simply y minus y sub 1 equals m times x minus x sub 1. Where x sub 1, y sub 1 is a point on the line, some point that we know both the x and y coordinate of, and where m is the slope of the line, the rise over run of the line, that shows up right here in the equation. That second point, simply whatever second point you want, would have to satisfy that equation. So in writing an equation like this, we'll leave the x and the y open, and any ordered pair x comma y that solves the equation has to be on the line as well. And that's really why this equation that you learned in Algebra 1 works. Let's work through a couple of examples together, and then I'll ask you to try one. This example says write an equation of the line through the ordered pair 6, negative 2 that also has a slope of negative 4. What I'd like to do is I'd like to use that point-slope form of the line equation, y minus y sub 1 equals m times x minus x sub 1. And I'll notice that this is my slope, negative 4. And I will choose to call this ordered pair x sub 1 comma y sub 1. And all I really need to do is to replace those values in the point-slope form equation, with their known values. So I'll say I need y minus the negative 2. Y minus y sub 1 equals the slope, negative 4, times x minus x sub 1, which is 6. Now that technically is an equation for the line. I want to write the equation in what we call slope-intercept form. In other words, I want to solve this for y. So I'm going to do a couple of things here. I'm going to choose to write y minus negative 2 as y plus 2. You might have written it down that way already. I'm going to distribute the negative 4. Negative 4 times x is negative 4x. Be very careful of the negative 4. When we distribute a negative number, we oftentimes miss the sign on that next term. This would be a positive 24. And then my last move to solve this would be to add a negative 2 to both sides. I think the line equation we're looking for is y equals negative 4x plus 22. Here's another similar example with a slightly different setup. This one says write an equation of the line through the ordered pair 2, 3 with a slope of 1/2. But even though the setup is slightly different, the thing that is different, by the way, is that the slope here is a fraction. It's not going to change what we do. It's just going to change. It'll make a little bit of the problem a little bit more complicated, but not that much more so. This is x sub 1, and this is y sub 1. Here's my slope still. So I need y minus the y coordinate I know, 3, which equals then 1/2 of the quantity x minus, and in this case I need the x coordinate 2. The next step would be to distribute this 1/2. So y minus 3 equals 1/2 x. What's half of negative 2? Well, it's negative 1. And I want to point out to you again that another way, I'll do this off to the side, you might not need to write this out, but one way to always multiply a whole number by a fraction is to always think of numerator times whole number divided by denominator. So 1 times 2 is 2, and 2 divided by 2 is 1. In this case it was negative 2, so I need a negative 1. That will always work. I suppose the last step here would be then to add 3 to both sides of the equation. How about an answer of something like y equals 1/2 x? This would be plus 2, wouldn't it? Y equals 1/2 x plus 2 seems to work. Alright, here's a chance for you to try one now. Write an equation of the line through the ordered pair 10, negative 2 that has a slope of negative 3/5. Pause the video, try it, and when you get an answer you like, hit play and we'll check it out. Alright, let's see. Y minus y sub 1 equals m times the quantity x minus x sub 1. This is the point slope form of the line. I know that this is x sub 1, this is y sub 1. This is my slope here. So we need y minus negative 2. I hope you're okay with me going ahead and writing that as y plus 2. If not, write it as y equals y minus negative 2, and then change the sign in your next step. Here we need negative 3/5 as the slope times the quantity x minus 10. And now I need to distribute. I need to distribute my negative 3/5 to both terms. I'll have y plus 2 equals negative 3/5 times x is negative 3/5 x. I'm going to go off to the side and do this one. Negative 3/5 times negative 10 is always top times number. Negative 3 times negative 10 is 30. 30 divided by 5 is 6. Please don't be afraid to write off to the side work for a problem that supports your answer if you need to. And now I'll subtract 2 from both sides. I'm going to go with y equals negative 3/5 x. And this would make plus 4. Thanks for watching.